All right, here we go. Welcome to video 1.4. This is actually just part 1, so I'm going to call it 1.4a. Make sure you, after this is over, watch part B, which is also on my webpage. I'm going to apologize in advance. This is going to probably be a little bit clunky because I need to switch between my Smartboard program and another program that you'll see here in a minute. Okay, so anyway, we're going to be learning about what are called position time graphs. In order for that to make sense to you, we need to learn, first of all, about what position is. So here's a simple definition of position. The symbol for position is simply the letter X, and we'll talk about why that is in a second. And basically what position does is it describes the location of an object. And to be honest, we've been looking at this already. We've seen it in the form of a number line, right? The number line basically just marks locations and it spreads them out over these numbers. So we need to pick a unit. So maybe this is in miles. So in this example, Bob's Triangle Store has a position of 12 miles, and the White Castle has a position of 3 miles. What we didn't see before is that you can also have a negative position if you go this way, right? So -1, -2, -3, -4, whatever. Okay. So I wanted to quickly talk about the X. Right now we're dealing with linear motion. So all of our motion occurs on a straight line. Eventually we will deal with two-dimensional motion, and then we'll have both an X position where the object is horizontally, and we'll also have a vertical position where the object is vertically. And in that case, your position would be called Y, right? So as a result, we use X. Now, we've seen X somewhere else too, displacement. Remember, the symbol for displacement is triangle X, right? And remember, the triangle just means change in. So let's think about why that would be. Well, suppose that you had somebody walk from, say, Sally's house to White Castle. All right. In that case, their initial position would be 7 miles. Their final position would be 3 miles. Okay. And in chemistry and in physics, you've learned that to find the change in something, you simply subtract, right? Like if the temperature goes from 80 degrees to 90 degrees, then the change in temperature is the difference between those two numbers, or 10 degrees. Here we're talking about the change in position. So it's, you always take the final and then subtract the initial. So our change in position, displacement, is just 3 miles, final position, minus our initial position, 7 miles, and it gives you -4 miles, right? Which makes sense, right? Because take a look at our drawing up here. If somebody walks from Sally's to White Castle, they're going to go 1, 2, 3, 4 miles in a negative direction. Okay? So that is that. So today what we're going to be talking about is what are called position time graphs, which combine this information that we see here on the screen with the time, right? If you imagine somebody walking, again, from Sally's to White Castle, that's going to take time. This drawing here doesn't represent the time. So what we're going to do is combine this information. Oh, lost my microphone. We're going to combine that information with the time to get what's called a position time graph. All right, and the way that we are going to do that is by using this program here. Whoa, we need to clear all of this out. So kaboom. Like I said, this might be a little clunky, so I apologize. All right, so what we've got up here is a number line, okay? The number line has position. Here's a position of 0. We actually call that the origin, okay? And then as you go this way on the number line, you get negative numbers, negative positions. And as you go this way on the number line, you get positive positions, all right? And if you look over here, there's a little dude standing here, right? So right now, his position is 10 meters. He's standing over here by the brick wall. Okay, but I can move him. So if I want, I can grab him and move him over to here. So now his position is 2 meters, right? Okay, or I can move him back to here, position of 4. Or I can move him over here, so he has a negative position. But notice, as that happens, tick, 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 time is ticking away, right? Okay, so it's going to take him time to move. Oops, let's try that again. It's going to take him time to move from one place to another, right? So what we need to do is find a way to keep all this information straight. Okay, so in order to do that, we can look at what's called a position time graph. Okay, so let me stop this for a second here. So this shows us the first 20 seconds worth of motion for our dude. Okay, when he first started, you'll remember his position was 10 meters, right? Because he was standing over here at the wall. And if you look at this graph, that's exactly what it tells us. This vertical axis here is a measure of the dude's position in meters. Unfortunately, the programmers did not label that for us. And the horizontal axis tells us how much time has passed. Okay, so I'm going to pause this for 1 second and clean up the screen. Oh, try that again. Okay, so what this is showing us then is that at time 0, when I first started moving the guy, his position was 10. All right, and then if you remember, I dragged him back to a position of 2. So if you look, after a little time, his position is 2. And then he stayed there for a little bit. So what this graph does is it tells us at any given time what the position is. So for example, 6 seconds after I started moving the dude, his position was, I don't know, about 4 meters, right? And he stayed there for a while, didn't he? Right? After 10 seconds after I started moving him, his position was -4. Okay? So this graph tells us all kinds of information. All right? So, what I'm going to do now, let me pause this again, and I'm going to clean up the screen a little bit. Okay, so I've done 2 things here. One, I reset our guy's starting position back to 0. You can see he's standing here at 0. Secondly, I opened up this other graph. The second graph tells us his velocity at a certain time. Okay, so what I'm going to do is I'm going to type in a velocity of, let's say, 0.5 meters per second. Okay, so his velocity is going to be 0.5 meters a second. Notice it's positive, and he's now facing in a positive direction, right? So he's going to walk this way at a rate of 0.5 meters per second. So let's write that out. Velocity is 0.5 meters per second. So what's that mean? It means every second he moves that way 0.5 meters. Okay, so let's click go and see what happens. All right, so here we go. Boom. Time is moving. Look, the time is elapsing up here. Time is elapsing, and as the time elapses, his position changes. Right now his position's 3, now his position's 4, now his position's 5. Here we can see how much time has passed. Right now there are 14 seconds elapsed, and he's at a position of 7. After 16 seconds, his position is 8. After 18 seconds, his position's 9. And then, bam, he runs into the wall. Okay? So, this is a position time graph. All right? You can see at any given time what his position is. You'll notice that it shows us, I don't know how else to say this, the time that's elapsed. Whoa, I really wish that hadn't just happened. Rats. Okay, I'm going to do this. Okay, I just drew the graph back in the way that it looked a second ago. But again, this tells us at any given time what his position is. You can see that as time goes on, right, like after 4 seconds, for example, his position is about 2. After 8 seconds, his position's about 4. So as time goes on, his position is increasing, right? As time goes on, his position increased, right? It went 2, 3, 4, 5, 6, and so on. Okay, so let me clear up the graph. Okay, so what I did here is I cleared off the graph a little bit and I wrote down some information. In that previous example, our dude started at a position of 0, so I wrote xi, as in position initial is 0, right? Because he started at 0. And I wrote down his velocity, was 0.5 meters a second. Okay, and this time what we're going to do is we're going to do kind of the same thing. We're going to start out with the same velocity of 0.5 meters a second, but notice this time our starting position is -8. Here's the dude hiding in the tree right there. Okay, so what we should expect this time is the position should start at -8 and then increase from there. All right, so let's click go and see what happens. Oh, fudge. The velocity didn't take. Let's try that again. I'm going to change the velocity to 0.5 and press enter this time. And then let's click go. There we go. All right, so that's okay. This was still instructive, right? So what happened is his position started at -8 and stayed -8 for a little while, right? And then it started increasing from there. Okay, I apparently just teleported the guy back in time, so he's doing it again. Okay, so yeah, I think that's all I have to say about that one. All right, so the last thing I want to do before we get to the next chunk of the video is, what do I do if I want to make the guy go the other way? Okay, so let me pause it. Okay, so we still have that first graph up there. This time, the way I've set it up is I've got his position starting at 0, which is why he's standing over here at 0. And this time I made his velocity negative. You'll notice he's facing now in a negative direction. All right, so this time what's going to happen is his position is going to decrease by 0.5 every second. All right, so let's click go and see what happens. The graph looks exactly like the first one, except it's upside down now, right? Because he's going backwards. So now we're at about 9 seconds, and his position was -5. His position is going to be -8 after 16 seconds. It's going to be -9 after 18 seconds, and after 20 seconds, he got to -10, right? Okay. So what we've just learned here then is that if your object moves in a positive direction, then the line slopes up. Slopes up if moving in a positive direction. So if your object moves that way, your line is going to slope up, and it'll slope down if you go in a negative direction, which should make sense, right? Because if you move this way, your position's increasing, right? These numbers are getting bigger. If you go this way, your position's decreasing, right? And so that's why it goes downhill. All right. So I'm going to pause the video there, and in the next video, we're going to look at what happens as the object speeds up or slows down. Okay? So before I stop the video, I guess, what should you have written down at this point? I guess I would have written down a couple things. I would have drawn some position time graphs. Okay? Make sure you remember that the axis over here is position, the horizontal axis is time. And then I would write this idea that if the graph slopes up, it means their position's increasing, which means they're moving forwards. And this, if it slopes down, it means their position's decreasing, which means they're going backwards. Okay, so I am really going to stop the video here, and the next video will be hopefully shorter, and we'll finish up this video. I'm going to stop talking now. Here we go. Oh, dang it.